When I was a boy, my father worked as a ticket collector at a merry-go-round in Revere Beach, at that time the Coney Island of Massachusetts. Kids loved to ride on flying horses that circled around and around. My dad told me of discussions he had with parents putting tiny tots on flying horses that seemed too fast for safety. If the ride seemed too fast, my dad suggested placing the child on horses nearer the center, away from the outer edge. He explained that horses near the outer edge moved faster. But many patrons insisted all horses moved around and around at the same speed. What was going on here? It seems there was confusion about two kinds of speed. One is the rotational speed of the merry-go-round, which, except for starting up and slowing down, was constant. Its rotations per minute, its RPMs, were constant. Just like a record player that rotated at a constant speed of 33 1/3 revolutions per minute, a rotating disc that played music before the advent of CDs and the like. Anywhere on the record, the RPM rate was the same 33 1/3 revolutions per minute. Such records are, by the way, still used by disc jockeys for mixing sounds, so they're not quite relegated to museums. Whether records or merry-go-rounds, RPMs on the inner part are the same as RPMs on the outer edge. Same everywhere. What's the other kind of speed? Linear speed, what we've been discussing in previous lessons. That's the miles per hour, feet per second, meters per second that describe how fast you're moving. Place a penny on a rotating disc and maybe it will stay and maybe it will fly off. Depends on the RPMs. But more important, how far the penny is from the center. The farther from the center, the faster its linear speed. See this? A penny circling near the outer edge moves a greater distance in the same time than a penny near the center when making a circle. It's easy to see the linear speed of the penny is greater near the outer edge. In fact, a penny near the outside might fly off the record while a penny near the inside won't. This is what my dad was trying to convey at the merry-go-round, that a child riding horses near the outer edge moved faster than horses closer to the center. In physics, we describe this as V is proportional to R omega. Speed V is directly proportional to the radial distance r from the center multiplied by the RPMs. We show rotational speed, say in RPMs, with the Greek symbol omega. Back to the merry-go-round. With a constant omega, linear speed v increases as radial distance from the center r increases. Look at this. My dad was right. Horses farther away from the axis of the merry-go-round, with greater radii, move faster. Greater radius r, greater linear speed v, with RPMs omega the same. Talking about merry-go-rounds, rotational motion, and record players reminds me of discussions in the old days in Miami, Florida, with sign painter friend Burl-Grey. One of the many puzzles he posed to me while painting billboards had to do with record players. Not the music they produced, but the mechanics of a rotating turntable. Burl was interested in what would happen if a small object such as a marble were placed on a record while rotating. He knew it would soon leave the edge, but he wondered about the path it would follow. Would the path curve? Would it be a straight line? And in what direction would the path take? To make the puzzle more interesting, Burl suggested the record have a heavy bar resting on it so that the marble or sliding object would be guided along a straight line before flying off the edge of the record. We enjoyed puzzles such as this while we painted daily. I ate it up, while other painting partners of Burl's had no use for such discussions. Burl and I became good friends, and our friendship continues to this day. Well, Burl's puzzle called for an experiment. I decided I'd impress my new friends and do the experiment. For I had a small record player at Miami apartment, which I'd place on the floor. Then I'd place a cooking utensil on it to act as the bar that Burl suggested. Then I'd watch to see the path of a marble as it rolled from the center off the edge. Furthermore, I'd do something really nifty. I'd sprinkle a bit of talcum powder on the floor so the path of the marble across the floor would clearly show. That was my plan. I was newly married at the time, and you know what? My wife and I went out to the movies that evening, and the following evening other things came along, and guess what? I forgot to carry out my experiment. Some years passed before I actually did the experiment. Do you know what they say about good intentions? So I leave the problem to you. Here we see 4 possible paths: A, B, C, and D. What's your take on this? When the marble rolls off the edge, will it follow path A, directly outward from the rotating record? Will it follow a curve, something like that of path B? Will it follow a straight line, as in C? Or will it follow a tangent, as in D? What's your choice? The answer to this question remained a secret from me for several years. Do you want me to tell you the answer? Can you keep a secret? Well, I can too. So maybe check with your friends. And what if your friends don't have an answer? Then maybe it's time to get some new friends. And if that doesn't work, maybe it's time to find a record player and a bit of talcum powder and experiment. Until next time, good energy.